Hello everyone, welcome back. So let's talk about this nice iron-carbon phase diagram. Now, some important things we need to talk about here are one, iron. Okay, it's 100% iron to start over here, and if we go over here, we get to 6.7% carbon. Okay, now you don't see anything past this. There is a phase diagram past this, it's just we're not going to go there because at this point, you begin going beyond it being steel and more towards it being pencil lead. Because over there at 100% carbon is graphite, which is pencil lead. And so obviously we don't need to know about that. The regions that are actually interesting to us are these three regions right here, the delta, the gamma, and the alpha. Gamma is austenite, the alpha is ferrite, and we'll get onto the delta's name later. So, with that being said, one other thing to think about is that this is a line right here. It is an intermetallic compound called cementite. 3 iron atoms, 1 carbon. And it's there because of stoichiometry. Now, it has a eutectic point right here, which is when we have a mixture of cementite and austenite. Okay? Cementite and austenite. It also has a eutectoid point, where we go from one solid structure to 2 different solid structures. Intermetallic compounds are considered solid structures. So this is my eutectoid point on the thing. This is my eutectic point. Sometimes in problems they'll say like you're just below the eutectoid. Like your concentration tells you where you are. Over here, the composition you have of carbon versus iron. However, the eutectoid point would be right here, so you would be just below this if they said just below the eutectoid point. Or just below this line if you say the eutectic point. So if I'm in this little section right here, right there, I am completely austenite at that point. Now there is carbon inside of that. Austenite is a primarily iron structure, and the iron is most definitely controlling the structure. However, there will be carbon impurities inside of that. They just don't form anything, they don't group together, they're just randomly sorted. And then when I cool down, we get these hopefully somewhat familiar lamellar structures. It's these nice kind of lines right here. You're like, wait a second, I thought it was for eutectic. And you're correct, it is for eutectic, it's also for eutectoid. And this is actually a structure that's called perlite, right here. These banded structure of cementite, which is hard, and the ferrite, which is soft, is called perlite. And depending on how quickly you make it, you can have either fine or coarse perlite. And here is a nice little look at it. So when we say it has that striped structure, it's real. It does actually have that striped structure. And it's for the same reasons we saw last time, where when we're at that right composition and we cool it down slow enough, then everything says, okay, well, I've got time to form these lines, because all of the carbon in this case, or I guess, sorry, the cementite in this case, wants to group with cementite, and all the ferrite wants to group with ferrite. Now, what happens if we're a hypoeutectoid or hypereutectoid? Remember last time we had hypoeutectic and hypereutectic? That's either before or after the eutectic point. In this case, we're saying, what if we have hypoeutectoid, so that's before the eutectoid point, or hypereutectoid? So let's look at it. Oh, I chose the wrong button. There we go. So first off, I start with just austenite. And I come down to that point, and once I reach that point just underneath that phase line, you'll see that the ferrite, which was before that point, just non-existent, begins to form. Okay, this is still mostly austenite at this point. Mostly austenite, but there is ferrite little globules beginning to form, because austenite is a mostly iron structure. Ferrite is most definitely a mostly iron structure, and it's just this combination of the two. The change in temperature is making me switch from one to the other. It's going to be going from face center cubic to bicenter cubic, and I'll let you look up and see what that change actually is. Now, as I get closer and closer to this eutectoid point, you'll see that those ferrite bands get larger and larger because we're moving further and further away from that edge. Remember, the amount of one metal you have is going to be related to how close you are to it. So I'm very closer now to the ferrite, so I begin to have more of the ferrite. Then I get past that eutectoid point. What happens is all of that austenite transitions into cementite and ferrite. So all the austenite disappears. And what's left behind is ferrite and cementite. So we have these pearlite sections with those ferrite bands in the middle. So when you have perlite is a mixture of ferrite and cementite. It's the perfect, like, just the right amounts mixture of ferrite and cementite. When you have extra of something, like in this case I've got extra ferrite, and so it's forming these little bands here, that's called proeutectoid ferrite. It says I've got too much of it, and so it didn't mix together right. And if we want to, we can then calculate the composition. For this one, I'm not going to bother going through this. These equations matter, and they're very, very helpful, but we'll do an example a little bit later to actually really jump into that. Now, if we're on the other side, we are hypoeutectoid steel, and that means that we're somewhere in between this point right here and this point right here. So it's going to be very, very similar to what we saw before. We have these austenite sections. We reach that point, and suddenly we have the cementite begin to form, and then that cementite turns into these little bands. After we pass that pearlite section, the cementite bands stay, and the pearlite forms with whatever's left of the austenite. And so this is a hypoeutectoid steel. You can see that proeutectoid cementite just means I had too much of it, so now all of it went to perlite, and then I have those bands, or those big sections of perlite in here. So you can see it kind of looks like cracks in the middle. And if we want to, we can then also calculate this. But just remember, whatever you're closest to, you're going to have more of that. So right now, I am far closer to austenite, so it's going to be a lot more austenite than cementite. And after I pass over, all of my austenite that I had beforehand turns to perlite. And everything else you can say, well, okay, well, overall, just looking at this, what is the composition? Because remember, there is ferrite inside of the perlite. So when I say the weight fraction of ferrite, I'm asking what's the weight fraction of all the ferrite in the system, like even if I've got proeutectoid ferrite. So don't get confused by that. It's one of those things that you have to practice a little bit. But just these are the weight fractions of the individual components. Just remember that they are inside of this. There's at least some of them inside of my perlite. Okay, so the perlite and those other two weight fractions are not separate. They are connected. Okay, that's it for this time. Thanks for listening, and I'll see you all later. Have an absolutely wonderful day. Bye-bye.